Who is Marie Curie? Marie Curie was a pioneering physicist and chemist who made groundbreaking contributions to the field of radioactivity. She was the first woman to receive a Nobel Prize in physics, the first person to receive 2 Nobel Prizes, the second in chemistry, and the first female professor at the University of Paris. Curie's discoveries and innovations had a profound impact on the development of modern physics and chemistry, including the use of radiation in medical treatments and the development of nuclear energy. She is widely regarded as one of the most important and influential scientists of the 20th century. Some text goes here: what inspired Marie Curie to pursue a career in science, and what were some of the challenges she faced as a woman in a male-dominated field? Some text goes here. Marie Curie was inspired to pursue a career in science from a young age, after being educated by her father and his colleagues. However, as a woman, she faced numerous challenges in the male-dominated field of science. She was unable to attend university in Poland due to her gender, and instead studied in secret at an underground floating university where women were allowed to study. Later, when she moved to France to pursue her studies, she faced discrimination and was denied admission to higher education institutions, forcing her to take on odd jobs and private tutoring to support herself. Even after she achieved success and recognition, she continued to face discrimination and skepticism from some of her male colleagues in the scientific community. Despite these obstacles, Curie persisted in her pursuit of scientific knowledge and went on to make groundbreaking discoveries in the field of radioactivity. Some text goes here: how did Marie Curie's groundbreaking research on radioactivity revolutionize our understanding of the nature of matter and energy? Some text goes here. Marie Curie's groundbreaking research on radioactivity fundamentally changed our understanding of the nature of matter and energy. Her work revealed that atoms were not the indestructible, indivisible units that had been previously thought, but were instead composed of smaller subatomic particles that could undergo spontaneous changes. Curie discovered 2 new elements, polonium and radium, both of which were highly radioactive, and she was able to isolate and study their properties. Her research showed that certain materials emitted radiation without any external stimulation, and that this radiation could penetrate matter and cause it to ionize. These discoveries had a profound impact on our understanding of the structure of matter and the nature of energy, and paved the way for further developments in nuclear physics and chemistry. Today, Curie's contributions to the field of radioactivity are considered some of the most significant discoveries in the history of science. Some text goes here: what was Marie Curie's role in World War I, and how did she contribute to the development of new medical technologies that helped to save countless lives on the battlefield? Some text goes here. During World War I, Marie Curie played an important role in the development of new medical technologies that helped to save countless lives on the battlefield. Curie recognized that the use of X-rays, which had been discovered by Wilhelm Röntgen in 1895, could be instrumental in the treatment of wounded soldiers. She therefore worked to establish mobile radiography units, or little Curies, that could be used on the front lines to diagnose and treat injuries. Curie herself drove these units to the front lines, sometimes in dangerous conditions, and trained medical personnel in their use. Her efforts helped to significantly reduce the number of unnecessary amputations and other surgical procedures, and saved countless lives. In recognition of her contributions, Curie was awarded the French Legion of Honor in 1915. Some text goes here: how did Marie Curie's discovery of radium and polonium lead to new medical treatments and diagnostic techniques, and what impact did this have on healthcare and medicine? Some text goes here. Marie Curie's discovery of radium and polonium had a profound impact on healthcare and medicine. Radioactivity, the phenomenon that Curie discovered, is the spontaneous emission of energy in the form of particles or electromagnetic waves from the nucleus of an atom. This emission can penetrate matter and can be used to both diagnose and treat diseases. Following her discovery, Curie and her husband Pierre worked to isolate radium and study its properties. They found that radium emitted a form of radiation that could penetrate human tissue, making it useful for treating cancer. Radium was also used in diagnostic techniques, such as X-ray radiography, to help diagnose medical conditions. The development of radiotherapy, or the use of radiation to treat cancer, was a direct result of Marie Curie's discovery. This treatment was revolutionary, as it allowed doctors to target cancerous tissue without the need for invasive surgeries. Radiotherapy continues to be used today, and has saved countless lives. Curie's work also paved the way for further research into radiation, leading to the development of other diagnostic techniques such as PET, positron emission tomography, scans, which use radioactive isotopes to detect metabolic activity in the body. The impact of Curie's work on healthcare and medicine cannot be overstated, and her legacy continues to inspire researchers and medical professionals today. Some text goes here. What was the significance of Marie Curie being the first woman to win a Nobel Prize, and how did this pave the way for future female scientists? Some text goes here. Marie Curie was the first woman to win a Nobel Prize and the first person to win it twice in different fields, physics and chemistry. Her groundbreaking work in the field of radioactivity challenged gender stereotypes and opened the doors for future generations of female scientists. She inspired women all over the world to pursue careers in science, and her achievements served as a reminder that gender should not be a barrier to pursuing one's passion. Curie's success also highlighted the need for greater inclusion of women in STEM fields and prompted the scientific community to recognize and value the contributions of women in science. Some text goes here. What were some of the controversies and challenges that Marie Curie faced in her personal and professional life, and how did she respond to them? Some text goes here. Marie Curie faced several controversies and challenges in her personal and professional life. Some of the notable ones are: 1. The controversies surrounding her personal life. After her husband Pierre Curie's tragic death in a road accident in 1906, Marie Curie became involved in a scandal when it was discovered that she was having an affair with a married physicist named Paul Langevin. This led to a public scandal, with the press attacking her character and questioning her morals. 2. The struggle for recognition as a woman in science. Marie Curie faced discrimination and prejudice because of her gender throughout her career. She was denied access to laboratories, equipment, and funding because she was a woman. She was also excluded from scientific societies and institutions because of her gender. 3. The health risks of her research. Marie Curie's work with radioactive materials exposed her to high levels of radiation, which led to health problems later in life. She suffered from chronic illnesses, including cataracts and leukemia, which ultimately caused her death. Despite these challenges, Marie Curie persisted in her work and made significant contributions to science. She continued to conduct research even when she was denied access to laboratories and funding. She also advocated for the use of scientific knowledge for the benefit of humanity, and her work paved the way for future generations of female scientists. Some text goes here. What was Marie Curie's legacy in terms of scientific discovery and innovation, and how has her work continued to influence modern science and technology? Some text goes here. Marie Curie's legacy in terms of scientific discovery and innovation is enormous. Her work on radioactivity revolutionized the field of physics and chemistry and led to groundbreaking discoveries that continue to shape our understanding of the natural world today. Her discovery of radium and polonium led to the development of new medical treatments and diagnostic techniques that have saved countless lives. Curie's legacy also extends beyond her scientific achievements. As a woman in a male-dominated field, she broke down barriers and paved the way for future generations of female scientists. Her dedication to scientific research and her passion for advancing knowledge continue to inspire scientists and researchers around the world. Some text goes here. What lessons can be learned from Marie Curie's life and career, both for aspiring scientists and for the broader public? Some text goes here. Some text goes here. How can determination and perseverance help individuals overcome challenges and achieve their goals, as demonstrated by Marie Curie's tireless pursuit of scientific discovery despite numerous obstacles? Some text goes here. Some text goes here. What is the importance of pursuing scientific research that has the potential to advance society, as demonstrated by Marie Curie's groundbreaking work on radioactivity and its applications in medicine? Some text goes here. Some text goes here. How can curiosity and a willingness to explore new ideas and areas of research lead to scientific breakthroughs, as demonstrated by Marie Curie's unconventional approach to science and her willingness to challenge established beliefs? Some text goes here. Some text goes here. What is the importance of diversity and inclusion in science, as demonstrated by Marie Curie's achievements as a woman in a male-dominated field, and how can we continue to work towards creating more equitable opportunities for underrepresented groups in science? Some text goes here. Some text goes here. What is the responsibility of scientists and researchers to use their knowledge and discoveries for the betterment of society, as demonstrated by Marie Curie's dedication to using her work to improve medical treatment and save lives? Some text goes here. Some text goes here. How did Marie Curie's work and achievements influence the field of nuclear physics and nuclear energy, and what is her legacy in this area? Some text goes here. Marie Curie's work on radioactivity and her discovery of radium and polonium had a significant impact on the field of nuclear physics and nuclear energy. Her research laid the foundation for further study of nuclear properties and the development of nuclear technology, which has since become a crucial part of modern society. Curie's work on radioactivity also led to the development of new medical applications, including radiation therapy for cancer treatment and the use of radioactive isotopes in medical imaging. This has transformed the field of medicine and led to countless lives being saved through earlier and more accurate diagnoses. However, Curie was also acutely aware of the potential dangers of radiation and the need for caution in its use. She advocated for safety measures to protect researchers and the public from the harmful effects of radiation, and her legacy continues to influence discussions on nuclear safety and regulation. Overall, Marie Curie's work on radioactivity has had a lasting impact on the field of nuclear physics, medicine, and technology, and her legacy as a pioneering scientist and advocate for safety and responsibility in science continues to inspire future generations. Some text goes here. What was the impact of Marie Curie's collaboration with her husband, Pierre Curie, and how did their partnership contribute to their scientific discoveries? Some text goes here. Marie Curie and her husband Pierre Curie had a close and fruitful partnership, collaborating on numerous scientific projects and discoveries. They first met in the late 19th century when Marie was looking for laboratory space to pursue her research, and Pierre, who was already a respected physicist, offered to help. They quickly fell in love and were married in 1895. Together, they conducted groundbreaking research on radioactivity and discovered two new elements, polonium and radium. They also developed new methods for measuring radioactivity and conducted extensive studies on the properties of radioactive materials. Their work laid the foundation for modern nuclear physics and led to numerous applications in medicine, industry, and energy production. Pierre's untimely death in a tragic accident in 1906 was a devastating loss for Marie, both personally and professionally. However, she continued to carry on their scientific work and went on to achieve numerous other accomplishments in her own right. Nevertheless, it is clear that Pierre's partnership and support played an important role in Marie's early scientific career and contributed significantly to their joint success in the field of radioactivity. Some text goes here. How did Marie Curie's research on radioactivity pave the way for future breakthroughs in areas such as cancer treatment and nuclear energy? Some text goes here. Marie Curie's research on radioactivity not only led to the discovery of new elements, but also paved the way for many future breakthroughs in various fields. One of the most important applications of radioactivity in medicine is in the treatment of cancer. Radiation therapy, which uses high-energy particles to destroy cancer cells, was first developed in the early 1900s based on Marie Curie's work. Marie Curie's research on radioactivity also had significant implications for nuclear energy. In the 1930s, Enrico Fermi, a physicist who had studied Curie's work, used nuclear fission to create the first controlled nuclear chain reaction, which led to the development of nuclear power plants and atomic bombs. Today, Another major challenge Newton faced was financial insecurity. He struggled to make ends meet throughout much of his life, often living off of small fellowships and grants. However, he was able to secure a more stable income through his appointment as warden and later Master of the Royal Mint, where he oversaw the production of England's currency. Newton also faced criticism and opposition from other scientists, who were skeptical of his ideas and theories. For example, his work on optics and light was initially met with skepticism, but he was eventually able to convince others of the validity of his ideas through his experiments and observations. Despite these challenges, Newton was able to make groundbreaking contributions to science, mathematics, and philosophy that continue to shape our understanding of the natural world today. Some text goes here. How did Newton's work lay the foundation for the scientific method in the Enlightenment, and what was his role in shaping the intellectual and cultural landscape of his time? Some text goes here. Isaac Newton's work had a profound impact on the scientific method and the intellectual culture of the Enlightenment. He is widely regarded as one of the founders of modern science, and his emphasis on empirical observation and mathematical rigor helped to establish the scientific method as a systematic approach to understanding the natural world. Newton's work on gravity and motion, as well as his development of calculus, laid the foundation for much of modern physics and mathematics. His ideas also helped to revolutionize the field of optics and paved the way for the development of modern telescopes and microscopes. In addition to his scientific contributions, Newton played a significant role in shaping the intellectual and cultural landscape of his time. His belief in the power of reason and observation to unlock the mysteries of the universe helped to inspire a generation of Enlightenment thinkers and philosophers. His influence can be seen in the work of other scientists and philosophers of the time, such as Voltaire and John Locke, and his ideas continue to shape our understanding of the natural world today. Some text goes here. What was Newton's personality and leadership style like, and how did his personal life and experiences influence his work and legacy? Some text goes here. As an AI language model, I do not have the ability to observe or interpret the personality and leadership style of historical figures like Isaac Newton, as I do not have personal or anecdotal knowledge. However, based on historical records, Newton was known for being a solitary and private person who preferred to work independently rather than collaborate with others. He was also known for being highly analytical and meticulous in his research, often spending years conducting experiments and collecting data before publishing his findings. Additionally, Newton's personal life was marked by some difficult experiences, including the death of his mother at a young age, his difficult relationships with colleagues and peers, and his struggles with mental health later in life. These experiences may have shaped his approach to science and his dedication to his work, but it is difficult to draw definitive conclusions about his personality and leadership style based on historical records alone. Some text goes here. What were some of the controversies and criticisms that Newton faced in his lifetime and in the centuries since, and how have historians and scholars evaluated his work and ideas over time? Some text goes here. Isaac Newton was one of the most celebrated scientists in history, but his work was not without controversy and criticism. Some of the controversies and criticisms he faced include: 1. Plagiarism. Some of Newton's work was accused of being plagiarized, particularly in the case of Gottfried Leibniz's work on calculus. The dispute over priority of discovery became known as the calculus controversy and continued for many years. 2. Unorthodox beliefs. Newton had unorthodox beliefs, including his interest in alchemy and his fascination with biblical prophecy. Some scholars have criticized him for his unconventional views and have argued that they may have influenced his scientific work. 3. Lack of social skills. Newton was known to be socially awkward and had difficulty relating to others. He was often irritable and had a reputation for being difficult to work with. 4. Ethical concerns. Newton's work on optics and the laws of motion involved experimentation on live animals, which some have criticized as unethical. Despite these controversies and criticisms, Newton's contributions to science and mathematics are widely regarded as groundbreaking and revolutionary, and his legacy continues to influence scientific research and discovery to this day. Some text goes here. How did Newton's ideas and theories shape subsequent scientific and technological developments, such as the Industrial Revolution and space exploration? Some text goes here. Isaac Newton's ideas and theories played a significant role in shaping subsequent scientific and technological developments. For example, 1. Industrial Revolution. Newton's laws of motion and his work on gravitation helped to create the scientific basis for modern engineering and mechanics, which in turn played a critical role in the Industrial Revolution. Newton's work helped to provide a foundation for the development of new technologies such as steam engines, which transformed manufacturing and transportation. 2. Space exploration. Newton's laws of motion and his work on gravitation also provided the basis for the development of space exploration. His insights helped to explain how objects move in space, and his mathematical theories provided the framework for modern space travel. 3. Modern physics. Newton's work on optics and light laid the groundwork for the development of modern physics. His experiments with light led to the discovery of the spectrum of colors, which helped to advance the study of physics and chemistry. Additionally, his theories of motion and gravity helped to inspire later scientists such as Albert Einstein to develop new ideas about the nature of space and time. Overall, Newton's ideas and theories have had a profound impact on science and technology, shaping the course of human history and opening up new frontiers of exploration and discovery. What is Newton's legacy in terms of his impact on modern science, mathematics, and philosophy? And how does he continue to inspire and influence new generations of thinkers and scholars? Isaac Newton is widely regarded as one of the greatest scientists in history, and his work laid the foundation for modern physics and mathematics. His discoveries and contributions have had a profound impact on many fields, including astronomy, optics, mechanics, and calculus. Newton's laws of motion and his theory of universal gravitation transformed our understanding of the natural world and paved the way for the scientific method and the Enlightenment. Newton's legacy extends far beyond his scientific and mathematical achievements. His leadership and contributions have influenced subsequent developments in technology, engineering, and space exploration. Newton's work on optics and light has played a key role in the development of modern optics, while his theories on gravitation continue to inform our understanding of the cosmos and our place in it. Overall, Newton's impact on science, mathematics, and philosophy has been enormous, and his legacy continues to inspire and influence new generations of thinkers and scholars.